Right, hi you guys. Title your notes today, please, complex fractions and unit rates. I'd like you to be taking notes while you watch. Pause the video if you need to. So we're going to kind of expand on lessons from earlier this week on unit rates, which we learned are rates that have a denominator equal to 1. And that's kind of what we're going to use to guide this lesson through today. What makes a unit rate complex is if there are fractions in the numerator, the denominator, or in both. So we see here that fractions like 1/3, 1/2, which sounds really weird, are called complex fractions. And we can use the basic idea of what we know about division to help us to simplify that down into a numerator and a denominator that are both integer values. So that's what our goal is going to be here. How are we going to do that? Well, we're going to do that by representing all of these as division problems, because we already know that this fraction bar, there are several fraction bars, but this fraction bar basically tells us that what we're solving here is 1/3 divided by 1/2. So let's do a quick review of dividing fractions. This should be quick. If we see a fraction over a fraction, we should know that what that means is 1/3 divided by 1/2, right? It's the numerator divided by the denominator. We should all remember that when we divide fractions, what we're really doing is multiplying by the reciprocal. So we want to take this complex fraction, we want to first rewrite it as a division problem. And then the next thing that we want to do is turn it into a multiplication problem so that we can solve it. So those are the steps that we're always going to use. We're going to set it up as a complex fraction. That's this guy. We're going to rewrite it as a division problem. We're going to solve it as a multiplication problem. So we know that what we're really doing here is 1/3 times 2/1, which has nothing to cross reduce, so we just multiply across to get 2/3. Here's our complex fraction. We're going to start by rewriting it as a division problem. 2/3 divided by 3/4. We're now going to multiply it and solve. So we've got 2/3 times 4/3 to get a value of 8/9. Here is our complex fraction. We're going to rewrite it as a division problem. 1/4 divided by 2. We're going to solve it as a multiplication problem. 1/4 times 1/2 to give us a value of 1/8. Okay, so these are the three steps we're going to follow. We're going to write it as a complex fraction, then we're going to set it up as a division problem, then we're going to solve it as a multiplication problem. So let's see how this works when we're actually trying to find a unit rate. Josh can jog 1 1/3 miles in 1/4 of an hour. We are looking for his average speed in miles per hour. So the first thing we have to understand is, how do we know which number goes in the numerator, which number goes in the denominator? I always look for the per. The per tells me which thing I want to get down to 1, or sometimes up to 1. I want to get the hours down to 1 or to equal 1, which means that this is the value that I'm going to put in the denominator. So I'm going to start with the first step of writing the complex fraction, which is 1 1/3, and I'm going to label it miles, over 1/4 hours. So we set it up first as this complex fraction. I knew to put the per in the denominator. I also knew that I had to label miles per hour. And why we do that is going to help us to understand how we're then going to answer our question. What it means is that when I answer the question, I'm going to be answering in miles per hour. All right, so let's set this up to divide. We've got 1 1/3, which we can just change right now to 4/3 divided by 1/4. We know that that means 4/3 times 4/1, and nothing to cross reduce, so we've got 16/3, or 5 1/3. So we now have our answer. Now let's talk about what we're finding. If you look at this setup, you see in the setup that we've got miles over hours, and since the thing that's in the denominator is what we want 1 of, what this is telling us is that our answer is 5 1/3 miles over 1 hour, or 5 1/3 miles per hour. Okay, let's try another. All right, a truck driver drove 350 miles in 8 3/4 hours. What is the speed of the truck in miles per hour? I'm just circling miles per hour so I know what goes in the denominator. It's the hours, the per, that goes in the denominator. So my setup is going to be 350 miles, there's my label, over 8 3/4 hours. Remember, the per, the thing I want one of, is in the denominator. And now I'm going to set it up to divide. 350 divided by 8 3/4 is 35 fourths. Let's set it up as a multiplication problem. 350 times 4/35. This is one of those nice reducing problems. I've got a 1 and a 10. And look at my answer. I've got 40 over 1, or just 40. But now the question is 40 what? That's where I go back to my setup. 40 miles per hour, or 40 miles per 1 hour. All right, let's take a look at Angie. Angie can walk 4 1/2 miles in 1 1/2 hours. Find her average speed in miles per hour. So I know what's going in the denominator. That's my per. So here we go. 4 1/2, I'm labeling miles, over 1 1/2 hours. And let's now divide it and multiply it and solve it. So 4 1/2 becomes 9 halves. We're dividing that by 1 1/2, which is 3 halves, which means 9 halves times 2/3. Lots of good cross reducing here. My 2's cancel out. My 3 and my 9 change to 1 and 3. And I've got an answer left of 3. 3 what is the question? Well, 3, there we go. Look at our setup. Miles per hour. All right, let's take a look at something that maybe isn't quite so obvious. Here we've got Anne mixes 1/2 cups of cranberry juice with 1/3 cups of orange juice. How much cranberry juice should Anne mix with 1 cup of orange juice? Remember what we said. The thing that is going to have the denominator of 1 is what, is how we find the unit rate. So what is it we're finding 1 of? We want 1 cup of orange juice, which means that my orange juice number, this, is what goes in the denominator. So look at my setup. I've got 1/2 cup of cranberry juice over 1/3 cup of orange juice. Oh, I wrote 1/2. I meant 1/3. I'm going to divide 1/2 by 1/3, which means I'm going to multiply 1/2 times 3 over 1 to get 3 halves, or 1 1/2. Now, you might be saying 1 1/2 what? That's where we go back to this. 1 1/2 cups of cranberry juice for every 1 cup of orange juice. So look at my answer. 1 1/2 cups of cranberry juice for every 1 cup of orange juice. Okay? So the 1, the thing we're finding the per, goes in the denominator. All right, same kind of thing. Ben can type 2/5 of a page of an essay in 1/2 a minute. How much time would it take him to type 1 full page of the essay? So let's think about what we're finding. 1 full page. So what goes in the denominator? The value that represents pages. So we're going to set this up as 1/2 minute over 2/5 pages. Why page? Because we're trying to find 1 of that. We want to know how long it will take him to type 1 full page. Here we go. 1/2 divided by 2/5 is equal to 1/2 times 5 halves. We've got 5/4, or 1 1/4. 1 1/4 what? Well, there is our what. 1 1/4 minutes per page. So the setup is the most important part, because if you set it up properly with the labels, your answer is just going to easily fall into place. All right, here's a Tom problem. Tom rode 3 1/2 kilometers in 3/4 of an hour. How far did he travel per hour? Per hour means this hour value goes in the denominator. I've got 3 1/2 kilometers over 3/4 hours. Let's divide. 3 1/2 is equal to 7 halves divided by 3/4, or 7 halves times 4/3. Let's cross reduce 1 and 2. And we've got 14/3, or 4 and 2/3. 4 and 2/3 what? If you set it up right, that's going to be easy. 4 and 2/3 kilometers per hour. All right, and we will finish with these last two problems. Let's blow these up a little. Nikki can walk 1 1/10 miles in 1/3 hour. Find her average speed in miles per hour. So what goes in the denominator? The hour value. We've got 1 1/10 miles over 1/3 hour. That is equal to 11/10 divided by 1/3, or 11/10 times 3/1. Multiply across to get 33/10, or 3 and 3/10. 3 and 3/10 what? 3 and 3/10 miles per hour. And our last problem is Andrea. Andrea can run 20 1/2 miles in 2 1/4 hours. How many miles per hour? Miles per hour can she run? So our hour is what goes in the denominator. We've got 20 1/2 miles over 2 1/4 hours. You see how important that label is. 20 1/2 is 41 halves divided by 9/4. That is 41 halves times 4 over 9. A little cross reducing to do. That gives us 82/9, which is equal to 9 1/9. 9 1/9 what? 9 1/9 miles per hour. That is a fast runner. All right, I think that that's it for today. So key things to remember. Key things to remember are, first of all, your setup. You want to set it up as a complex fraction or ratio, however you want to call that. Use labels. So you need to make sure to label, because you see how important that label is going to be when you get your answer. 2, you're going to rewrite it the long way as a division problem. Don't just skip to multiplying by the reciprocal. I want to see that you understand how the fraction relates to turning it into division. Finally, you're going to multiply by the reciprocal to solve. And lastly, you're going to go back to how you set it up and label it so I can see that it's a unit rate. So label in miles per hours, or feet per second, or cranberry juice to orange juice, whatever it may be, okay? And the setup is what's really going to help you with finding that label. All right, guys, miss you. Hope to see you tomorrow. Bye-bye. Thank you, guys. Yeah.